25th, Hubble recorded an almost unbelievable discovery on 3I Atlas. This object is displaying a geometric structure so precise it is difficult to comprehend, challenging conventional astrophysical models. By using a specialized image processing filter, researchers peeled away the surrounding coma to reveal a system of 3 perfectly symmetrical gas jets, separated by exactly 120 degrees. Even more striking, they also detected a 4th, stronger jet that could function as a primary propulsion engine, making the entire configuration resemble an engineered design rather than a natural phenomenon. The remarkable stability of this structure over 2 months, combined with a 7.1-hour rotation period, has contributed to a growing list of 18 anomalies, and it is precisely this stacking chain of anomalies that is making the hypothesis of an extraterrestrial technological object more plausible than ever before. When 3 Atlas is viewed through raw telescope frames, the first impression is almost always the same, a soft halo of dust and gas that feels familiar to anyone who has ever watched a comet pass through the inner solar system. 3. I Atlas appears wrapped in a luminous fog, and that fog is exactly what makes 3 Atlas so difficult to judge with honesty. The coma around 3 Atlas is not a decoration, because the coma around 3 Atlas is an active physical system made of scattering particles that blur edges, erase boundaries, and hide the nucleus in plain sight. If the goal is to understand whether 3I Atlas is behaving like a normal sublimating body, then the coma of 3I Atlas becomes both the evidence and the obstruction at the same time. 3I Atlas can look ordinary precisely because the coma of 3I Atlas makes ordinary shapes easy to project onto uncertainty. This is why researchers turn to a technique known as the Larsen-Sechenina filter, because the Larsen-Sechenina filter is designed to remove what is symmetrical and reveal what is structured. The Larsen-Sechenina filter begins with a simple idea that becomes powerful in practice, where an image of 3 Atlas is rotated by a chosen angle and then subtracted from the original frame so that circularly symmetric features cancel out. When the bright, nearly round glow of the coma around 3I Atlas is mathematically reduced, the remaining pixels are no longer dominated by haze, and the remaining pixels begin to hint at edges, jets, and geometry that the eye could not isolate before. The data here is not mystical, because the data is just light captured by a sensor, but the processing changes the question from what does 3I Atlas look like to what survives subtraction when symmetry is removed. That shift matters because symmetry is what nature produces easily in a cloud, while structure is what 3I Atlas must physically sustain at the source. If 3I Atlas were only a chaotic ice ball venting at random, then the subtraction would mostly reveal turbulence, noise, and unstable fragments, and 3 Atlas would remain a blur in a different costume. Instead, the Larsen-Sechenina approach treats 3 Atlas like a puzzle with layers, where the outer brightness is peeled away so the core behavior of 3 Atlas can be inspected without the glare. 3 Atlas becomes less like a fuzzy object and more like a set of constraints, because whatever remains after the coma is suppressed must be anchored to the body of 3 Atlas itself, and once 3 Atlas is reduced to what is persistent rather than what is bright, the investigation can finally move forward, because 3 Atlas stops being a pretty glow and starts becoming a pattern that demands explanation. 3 Atlas becomes truly difficult to dismiss when the coma is no longer allowed to dominate the frame, because once the symmetric glow is reduced, 3 Atlas is forced to reveal what the haze had been hiding. In the processed view, 3 Atlas does not present a single messy plume or a random scatter of vents, but 3 Atlas presents a triad, 3 compact mini-jets arranged with a balance that feels almost too clean to be accidental. 3 Atlas shows 3 discrete outflows, and the spacing between those outflows is not approximate or loosely aesthetic, because 3 Atlas holds them apart at a near-perfect 120 degrees. The data is simple in appearance yet heavy in implication, because the human brain recognizes symmetry instantly, and 3 Atlas is offering symmetry at a scale where geology rarely cooperates. 3 Atlas is not showing the kind of asymmetry you would expect from a surface fractured by thermal stress, where one vent dominates and the others flicker, but 3 Atlas is showing 3 sources that appear coordinated, as if the surface activity of 3 Atlas is locked into a repeating arrangement. If 3 Atlas were venting through a single weak spot, then one jet would naturally steal the show, yet 3 Atlas distributes the behavior across 3 points like a system sharing a load. This is where the anomaly sharpens, because the number is not just 3, and the angle is not just neat, but 3 at last is displaying a geometry that engineers would describe as stable, efficient, and evenly spaced. 3I at last is forcing a question that does not belong to ordinary comet language, because ordinary comet language expects irregularity, while 3I at last is presenting a pattern that resembles design constraints. 3I at last makes the observer wonder whether the jets are simply vents, or whether the jets on 3I at last behave more like nodes in a control scheme that is trying to avoid imbalance. The emotional weight here is quiet rather than loud, because 3I at last is not screaming with obvious machinery, and 3I at last is not broadcasting a signal in plain language. 3I at last is doing something subtler, where the discomfort comes from precision, and where the fear comes from the possibility that precision is not free. And as the triad holds its shape in the processed frames, 3I at last invites the next step, because the only honest response is to ask whether this geometry persists, and whether 3I at last can keep repeating the same 120-degree signature as time moves forward. A reasonable mind does not accept a single striking frame as proof, because a single moment can be a coincidence, and 3I at last is still a body moving through a harsh environment where sudden outbursts are possible. 3I at last could, in principle, produce a transient triad if a one-time fracture opened along a convenient set of weaknesses, and 3I at last could briefly vent in a way that only looks organized because the timing happened to align with our observation. 3. Atlas could even appear symmetric if the viewing angle flattened a messy three-dimensional reality into a clean two-dimensional illusion, and 3I Atlas would not need to be extraordinary for the eye to be fooled. That is why skepticism becomes part of the method, because skepticism is the tool that prevents curiosity from turning into certainty too quickly. The correct question is not whether 3I at last can look strange once, but whether 3I at last can remain strange when the universe is given time to disrupt the illusion. If the mini-jets on 3I at last were truly random, then the angles should drift, the relative brightness should swap, and the arrangement should deform as the surface of 3I at last heats, cools, cracks, and evolves. In natural comet behavior, stability is rare, because jets migrate as volatiles deplete, and jets fade as pockets empty, and jets relocate when new vents open, and 3I at last should not be exempt from that physics. 3I at last is also subjected to changing illumination and changing geometry, meaning the same vent on 3I at last should not always project the same way to a distant observer. So the scientific rebuttal becomes a simple demand, where the triad must either dissolve into noise, or the triad must prove it is more than a temporary flare. The emotion here is controlled, because the goal is not to believe in a mystery, but to test whether 3I Atlas is offering a repeatable signature, and once that standard is set, the story naturally turns outward, because the next step is to search beyond one frame, and to ask whether 3I Atlas carries the same geometry across many observations, as if 3I Atlas is not improvising at all. The moment the archive is opened, the debate changes, because the question stops being what 3I Atlas did once, and becomes what 3I Atlas keeps doing when no one is trying to be impressed. Across many separate observations spread over weeks, the same processed approach continues to reveal the same underlying signature, where 3I Atlas repeatedly shows 3 compact mini-jets, separated by the same clean geometry. 3I Atlas does not behave like a surface that is improvising under stress, because 3I Atlas returns to the same arrangement again and again, as if the pattern is anchored deeper than a fragile crust. This persistence matters more than the beauty of symmetry, because persistence is what turns a striking image into a scientific constraint. If 3I Atlas were merely venting through random cracks, then time would be the enemy of order, and 3I Atlas would gradually drift away from the neat 120-degree separation as vents evolved. Instead, 3I Atlas holds the spacing with a stability that suggests the source regions are fixed relative to the body, and 3I Atlas begins to look less like chaos and more like architecture. Now the geometry forces a second level of reasoning, because what we see is not the object itself, but a projection of 3I Atlas onto the plane of the sky. For 3I Atlas to repeatedly appear in such balanced separation, the most economical explanation is that the jets are arranged on a plane or on a cone, whose symmetry is intrinsic to 3I Atlas. A triad placed on a circular ring around the nucleus of 3I Atlas, or a triad aligned around a cone centered on a rotation axis, would naturally reproduce the same angular spacing even as the viewing conditions shift. The emotional conclusion of this chapter is not a declaration, because 3 Atlas still allows natural interpretations, and 3 Atlas still hides its true shape behind distance. But the calm unease grows, because 3 Atlas has crossed a line from a one-time curiosity into a persistent pattern, and 3 Atlas now demands that we stop describing and start explaining. Once the triad becomes a repeatable feature, 3 Atlas invites a deeper look, because a stable pattern rarely arrives alone, and 3 Atlas begins to reveal a second structure that changes the balance of the scene. Alongside the 3 compact mini-jets, 3 Atlas shows an additional outflow that is longer, more forceful in appearance, and distinct in direction, as if 3 Atlas is not only expressing symmetry, but also expressing a dominant axis. 3 Atlas now reads as a 3+1 configuration, where the triad provides the evenly spaced geometry, and the extra jet provides an asymmetry that feels purposeful rather than accidental. In ordinary comet language, jets are vents, and vents are the result of sunlight waking volatile pockets beneath a surface. But 3 Atlas complicates that simplicity by combining balance with a single standout feature. 3 Atlas looks like a system that can both stabilize and push, because 3 jets arranged at 120 degrees can distribute forces, while one larger jet can provide a primary impulse. 3 Atlas does not need to be artificial for this to happen, yet 3 Atlas forces the mind to notice how closely this resembles the logic of control, where symmetry prevents tumbling and a main channel provides direction. The anomaly is not that 3 Atlas has jets, because comets have jets all the time, but the anomaly is that 3 Atlas organizes the scene into roles. 3 Atlas feels less like a random venting surface, and more like a body expressing function through geometry, and 3 Atlas quietly sets the stage for the next question, which is not what the jets look like, but how the jets move as 3 Atlas rotates through the dark. When the motion of the jets is examined over time, 3 Atlas stops being a photograph and becomes a rhythm, because the structure around 3 Atlas is not frozen in place, but oscillates with a steadiness that feels like a clock. The triad on 3 Atlas does not simply spin as a rigid pattern on a fixed axis, because the entire jet geometry of 3 Atlas appears to wobble, drifting back and forth by roughly 20 degrees as the system turns. 3 Atlas therefore presents 2 motions at once, a rotation that repeats, and an oscillation that breathes, and the combination makes 3 Atlas feel less like a tumbling rock and more like a controlled dance. The data suggests a repeat period of about 7.1 hours, and that number becomes the heartbeat of 3 Atlas, because it implies a fundamental rotation timescale for the nucleus itself. If 3 Atlas were only spinning cleanly, the jets would trace a stable path relative to the observer, but the wobble indicates that the spin axis of 3 Atlas is not perfectly aligned with the jet plane, or that the active regions on 3 Atlas are tilted relative to the body's principal axis. 3 Atlas therefore behaves like a system whose geometry is slightly misregistered, and that misregistration is what produces the rhythmic sweep we can measure. To visualize this without forcing the mind to strain, imagine a lighthouse turning on a distant coast, because the lighthouse analogy matches what 3 Atlas is doing in space. If the beam of a lighthouse is perfectly perpendicular to the rotation axis, the beam sweeps a clean flat circle across the horizon, but if the lamp is tilted, the beam traces a cone, rising and falling as it rotates. 3i Atlas mirrors that behavior, because each mini-jet on 3i Atlas behaves like a beam that is not perfectly centered, and the result is a repeating oscillation that is gentle, predictable, and strangely precise. The emotion here is a quiet unease, because precision at this scale is not common, and 3 Atlas is offering precision while also offering power. And once the 7.1 hour rhythm is accepted as real, 3 Atlas naturally leads to the next problem, because any jet that throws mass into space also throws force back into the body, meaning 3 Atlas must be absorbing torque without losing its composure. The moment jets are treated as more than scenery, the physics becomes unavoidable, because every stream of gas leaving 3 Atlas is also a push acting on 3 Atlas in the opposite direction. By Newton's third law, the outflow from 3 Atlas is a thruster, whether we want to call it that or not, and the combined effect of multiple jets on 3 Atlas should generate torques that twist the nucleus over time. 3 Atlas is therefore not only shedding material, but 3 Atlas is also being mechanically torqued by its own activity, and that torque should matter most when the geometry is asymmetric or time-varying. If 3 Atlas were a rubble pile, meaning a loose aggregate held together by weak gravity and fragile cohesion, then a strong persistent jet pattern would be a stress test that 3 Atlas should fail. 3 at last should either spin up until it fragments, or 3 at last should spin down into a sluggish drift, or 3 at last should enter a chaotic tumble where the rotation axis wanders unpredictably. 3 atlas should not, under the simplest natural expectations, maintain a clean rhythm while also maintaining a stable geometric signature, because the forces involved should rewrite the spin state of 3 atlas in a short timescale. Yet the observational story refuses to follow that script because 3 atlas keeps returning to the same 7.1 hour beat and the same wobbling structure as if the system is self-consistent. 3 atlas does not look like an object losing control, and 3 atlas does not look like a body tearing itself apart, which makes the paradox sharper rather than softer. The emotion is not panic because science does not need panic, but the discomfort deepens because 3 atlas is behaving as if there is a stabilizing influence inside 3 atlas that we have not accounted for. And once that possibility is admitted, 3 atlas pushes the narrative forward, because the next step is to ask what kind of damping could exist naturally, and what kind of control could exist intentionally, without rushing to choose an answer. If 3 atlas is absorbing torque without falling apart, then 3 atlas must be doing something that ordinary intuition does not automatically grant to a fragile comet, because stability under persistent forcing is not free. One possibility is that 3 atlas contains a natural damping mechanism, where internal friction, structural cohesion, or an unusual mass distribution within 3 atlas bleeds rotational energy away in a way that smooths the evolution of the spin state. 3 atlas could, for example, be more monolithic than expected, or 3 atlas could be layered in a way that locks the active regions into a rigid framework, allowing 3 atlas to behave like a solid body rather than a loose pile of debris. Another possibility is that the jets on 3 atlas are arranged in a configuration that cancels much of their own destabilizing influence, because symmetry is not only beautiful, but also mechanically useful. 3 atlas, with 3 mini-jets spaced at 120 degrees, can distribute reaction forces in a balanced way, and 3 atlas can reduce net tumbling even while mass is being expelled. In that interpretation, the wobble of 3 atlas becomes a controlled oscillation rather than a sign of breakdown, and the 7.1 hour rhythm of 3 atlas becomes a maintained state rather than a decaying one. But there is a third hypothesis that cannot be ignored once the word control enters the room, because if the system behaves like it is maintaining stability, then it is fair to ask whether stability is being maintained actively. This does not require science fiction, because active control is simply the idea that 3 atlas could be adjusting its own outflow in response to its own motion, creating a feedback loop that holds the spin state within a narrow range. 3 atlas would then resemble a mechanical system, where the jets are not only consequences of heating, but the jets on 3 atlas become part of a self-regulating process. The emotional tension here is gentle but persistent, because the evidence does not shout, and 3 atlas does not offer a label for what it is. 3 atlas only offers behavior, and behavior is the language of physics. So the research question opens naturally, because the next step is not to decide what 3 atlas is, but to ask what 3 atlas resembles when its geometry is translated into the vocabulary of engineering. At a certain point the language must change, because the same data can feel ordinary or extraordinary depending on the frame we place around it, and 3 atlas has reached the point where comet language begins to strain. If we keep calling every outflow on 3 atlas a vent, then 3 atlas remains a passive object reacting to sunlight, but if we acknowledge that every vent on 3 atlas produces force, then 3 atlas becomes an active participant in its own motion. 3 atlas does not need intention for this to be true, because physics supplies the push automatically, yet 3 atlas forces us to admit that jets are functionally thrusters, whether we prefer the word or not. This pivot is not a leap into fantasy, because it is simply a shift from chemistry to mechanics, and 3 atlas becomes a system of forces rather than a cloud of sublimation. When the triad of mini-jets on 3 atlas is held at a clean 120-degree spacing, the arrangement begins to look like a layout designed to balance torque, and when the additional jet on 3 atlas extends farther and dominates the morphology, it begins to look like a primary channel of impulse. 3 atlas therefore invites an engineering question, not because we want an engineered answer, but because 3 atlas is presenting geometry that engineering would recognize as useful. The emotion here is a quiet shift from wonder to scrutiny, because once the word thruster is allowed, 3 atlas stops being a spectacle and becomes a machine-like problem, And with that reframing in place, 3i Atlas naturally leads into the next layer, where we ask what experts in spacecraft dynamics would see when they look at the same 3+1 pattern in the dark. When specialists in dynamics and engineering look at a pattern, they do not only see shape because they see constraints, and 3i Atlas presents constraints with an unsettling elegance. The observation that 3i Atlas maintains 3 mini-jets spaced at 120 degrees is not merely a visual curiosity, because macroscopic symmetry of that kind is rare in natural geology, where fractures, vents, and weak points tend to emerge from disorder. 3i Atlas is not a crystal growing in a laboratory dish, and 3i Atlas is not a microscopic structure governed by lattice rules, but 3i Atlas is a large body exposed to heat, stress, and erosion, where symmetry is usually temporary. This is why the perspective associated with Frank Lock-in becomes relevant, because the argument is not that nature cannot produce beauty, but that nature rarely maintains engineered regularity at scale without a strong underlying reason. 3 Atlas, in that view, looks less like 3 accidental vents and more like 3 nodes placed to share a load, and the additional jet on 3i Atlas looks like a dominant channel that completes a functional layout. 3i Atlas therefore begins to resemble the kinds of arrangements used in reaction control systems, where spacing is chosen to create predictable torques and to avoid unwanted tumbling. The emotional weight of this comparison is subtle, because 3i Atlas is not being declared artificial, and 3i Atlas is not being promoted as a certainty. But the comparison matters, because it forces a new question into the open, where the geometry of 3i Atlas is no longer judged by what comets usually do, but by what stable systems must do when they need to move through a vacuum without losing control. If 3i Atlas is treated as a mechanical system, then the 3+1 configuration on 3i Atlas begins to look like a minimum viable solution to a familiar problem, which is how to change motion without surrendering stability. In spacecraft design, a fully capable thruster layout often uses opposing pairs so that rotation can be induced without unwanted translation, and translation can be induced without unwanted rotation, because control in 3 dimensions is expensive in mass. 3i Atlas, however, is not offering a textbook array of 6 thrusters, and 3i Atlas is not showing a messy forest of vents either, but 3i Atlas is showing something simpler, more economical, and strangely complete. The triad of mini-jets on 3 Atlas, spaced at 120 degrees, can be interpreted as an attitude control layer, because 3 evenly spaced force vectors can produce balanced torques and can adjust orientation without driving the body into chaotic tumble. 3 Atlas, by distributing these mini-jets around a shared plane, would be able to nudge its spin state while preserving symmetry, and 3 Atlas would naturally resist the kinds of asymmetric forcing that destabilize fragile rotators. In that same frame, the larger anti-tail jet on 3 Atlas becomes a candidate for primary impulse, because a single dominant outflow can provide a sustained push, a delta V, that changes the trajectory over time. This division of roles is not proof of intention, because natural processes can sometimes mimic functional layouts, yet 3 Atlas makes the mimicry feel unusually tight. 3 Atlas appears to separate steering from propulsion, where the triad can stabilize and the single major jet can accelerate, and the wobble of 3 Atlas can be reinterpreted as the visible consequence of small steering corrections acting on a spinning body. 3 Atlas therefore becomes a problem that sounds less like comet chemistry and more like efficiency, because in a vacuum, efficiency is not a preference, it is survival. The emotion in this section is not fear, but fascination, because the idea is only a hypothesis, and 3 Atlas still has many natural explanations available. But the hypothesis earns its place, because 3 Atlas is presenting a geometry that matches what minimal control would look like, and 3 Atlas invites us to ask whether the simpler stable answer is also the most unsettling one. A rotating body carries its own kind of order, because spin creates stability, and 3 Atlas appears to live inside that principle with unusual consistency. When 3 Atlas turns with a repeatable rhythm, near 7.1 hours, 3 Atlas is not only marking time, but 3 Atlas is also generating gyroscopic stiffness, the same stabilizing behavior that keeps a spinning top upright and keeps a thrown football from tumbling wildly. 3 Atlas therefore gains a free axis of stability simply by rotating, and that stability changes what a control system would need in order to steer efficiently. In a spin-stabilized spacecraft, you do not always need a dense forest of thrusters, because the spin itself resists disturbances and smooths out smaller symmetries over each rotation cycle. 3i at last, if 3 at last is effectively spin stabilized, could rely on a smaller set of impulses to adjust its orientation, because the body would naturally average out irregular forces while maintaining a preferred axis. This makes the triad on 3 at last feel even more mechanically appropriate, because 3 evenly spaced mini-jets can provide gentle, periodic corrections that align with the rhythm rather than fighting against it. The wobble observed in the jet structure of 3 at last can also be placed into this frame, because wobble does not always mean loss of control, and wobble can be the visible trace of precession in a system that is stable but not perfectly aligned. 3 at last could be precessing because the mass distribution inside 3 at last is not uniform, or 3 at last could be precessing because outgassing torques are nudging the spin axis in a predictable cycle. Either way, 3 at last remains coherent, and coherence is the clue that keeps returning, because 3 at last continues to behave like a body that is managing its own motion rather than being dragged by it. The emotion here becomes almost meditative, because the idea of spin stabilization makes the system feel quiet and controlled, as if 3i at last is moving with intention even if no intention exists. And once spin is recognized as a stabilizer, 3i at last leads to a practical prediction, because the geometry of the jets should reveal itself most clearly when the viewing angle becomes perfect, and the universe is about to offer that alignment. There are moments in observation when the universe seems to simplify the experiment for us, and 3 at last is approaching one of those moments, because geometry can briefly remove ambiguity that weeks of analysis cannot fully erase. Most of the time, when 3i at last is seen from Earth, 3i at last is flattened into a projection, and the true three-dimensional arrangement of jets around 3i at last is compressed into a two-dimensional image on the plane of the sky. 3i at last can therefore look stretched or tilted or distorted, not because 3i at last is changing its structure, but because the viewing angle changes what the structure can look like from far away. This is why a near-perfect alignment becomes so valuable, because alignment is a natural experiment that cancels projection effects without asking the observer to guess. For 3 at last, the alignment window is defined by an angular offset of only about 0.69 degrees from the anti-solar direction, meaning the line from the Sun through 3 at last toward Earth becomes almost perfectly straight. 3 at last will be seen from a perspective that is rarely available for any transient object, and 3 at last will be placed into a viewing geometry that acts like a truth serum for structure. To picture this gently, imagine a flashlight in a dark room, because the flashlight analogy captures what projection does to our perception. If you look at the flashlight beam from the side, you see a long shaft of light, and the beam can appear thick or thin depending on the angle. But if you look directly down the barrel, the beam collapses into a bright circle. 3 at last has been shown to carry a jet system that behaves like a rotating pattern, and under this alignment, the rotating geometry of 3 at last may stop looking like flattened arcs and begin looking like its true face. The data we already have suggests that the rotation axis of 3 at last may be oriented close to the sunward direction, and if that hypothesis is correct, then this alignment should amplify the signature rather than hide it. 3 at last would then be seen almost head-on relative to the axis, and the triad on 3 at last would trace a cleaner, more symmetrical path across the image plane. 3 at last would not need complex unprojection algorithms to reveal its spacing, because the universe itself would perform the unprojection for us. The emotional tension here is calm but unmistakable, because 3 at last is about to face a test that cannot be negotiated with interpretation. And as this alignment approaches, 3 at last invites the next step in the loop, because a test is only meaningful when it comes with a prediction that can be right or wrong in plain sight. A scientific alignment is only as valuable as the prediction it allows, and 3 at last now offers a prediction that is both simple to state and difficult to dismiss. If the jet system of 3 at last is arranged in a symmetric configuration around a stable axis, then the near head-on viewing geometry should cause the rotating mini-jets of 3 at last to trace a pattern that appears circular rather than distorted. 3 at last has been seen as flattened structures because of projection, but under this alignment 3 at last should reveal a cleaner clock face view, where the spacing of the triad becomes easier to measure without interpretation. In that scenario, the 3 mini-jets on 3i at last would not merely appear separated by 120 degrees, but 3i at last would display that separation in a way that survives the collapse of perspective, 3i Atlas would either maintain the symmetry as a true structural feature, or 3i Atlas would allow the symmetry to break when the viewing angle removes the illusion, and that binary outcome is exactly what makes this a useful test. 3i Atlas cannot pass or fail this prediction quietly, because the geometry will either tighten into clarity or loosen into complexity. At the same time, the alignment is expected to enhance visibility through a separate physical effect, because when the sun is nearly behind the observer, shadows on rough surfaces disappear and scattering behavior changes. This is the regime often described as an opposition surge, where brightness can increase non-linearly, and 3 Atlas may briefly appear more luminous, not because 3 Atlas has changed, but because the light is returning to the observer more efficiently. 3 Atlas would therefore offer a higher signal-to-noise ratio, and that improvement matters because faint structures are the first things to vanish into noise and the first things to return when the noise floor drops. With better signal, subtle boundaries around the jets of 3i Atlas could become sharper, and weak secondary features near the triad of 3i Atlas could become detectable for the first time. 3i Atlas might reveal whether the mini-jets are isolated streams or parts of a broader ring, and 3i Atlas might show whether the dominant jet behaves like a single channel or a layered plume. 3i Atlas therefore turns this window into more than a spectacle, because the same geometry that feels unsettling in low clarity becomes testable in high clarity. The emotion in this prediction is a controlled anticipation, because 3i Atlas is not being asked to prove a story, and 3i Atlas is only being asked to show its shape from a better angle. And once that prediction is placed on the table, 3i Atlas carries us forward again, because the meaning of the result will depend on the broader context of how many other anomalies 3i Atlas has already accumulated. The symmetry of the jets would be compelling on its own, but 3 Atlas does not arrive with only one oddity, because the story of 3 Atlas has been building through a layered accumulation of inconsistencies. When researchers speak of 3 Atlas exhibiting 18 distinct anomalies, they are not describing a single mystery that can be hand-waved away, but they are describing a scoreboard of rare behaviours that compound the improbability of chance. 3 Atlas can be forgiven for one outlier, and 3i Atlas can even be forgiven for 2, because nature is capable of producing rare combinations, yet 3i Atlas begins to strain that generosity when the list keeps growing. The deeper issue is statistical, because each anomaly narrows the space of natural explanations, and the intersection of many anomalies becomes a smaller and smaller target for randomness to hit. 3i Atlas therefore begins to resemble a loaded die, not because anyone has proven it is loaded, but because repeated extreme outcomes invite the question of whether the assumptions about the die are incomplete. 3i Atlas does not need to be artificial for this logic to hold, because the point is not certainty, but the necessity of re-evaluating priors when evidence piles up. This is where a framework like the Loeb scale becomes useful, because classification systems exist to quantify uncertainty rather than to replace it with belief. 3. I Atlas can be placed along a spectrum where unknown does not mean impossible, and where likely artificial does not mean proven artificial, but where the ranking reflects how many constraints the object has imposed on conventional models. 3i Atlas, with a stable triad geometry, a persistent rhythmic wobble, and a configuration that echoes mechanical efficiency, begins to drift upward on that scale, because the patterns are not isolated, they are connected. The emotion here is not triumph, because science is not a victory lap, and 3 Atlas is not a trophy. The emotion is a sober widening of possibility, because 3 Atlas is forcing language like technosignature to enter the conversation as a hypothesis rather than a headline. And as 3 Atlas approaches the alignment test, the narrative becomes almost quiet again, because the final movement is not to declare an answer, but to let the geometry decide how far the question is allowed to go. In the end, the most important discipline is not the ability to imagine, but the ability to remain honest when the universe replies, and 3 Atlas is about to offer a reply in the language of geometry. If the alignment reveals a clean circular signature, then 3 Atlas will strengthen the case that the triad is intrinsic and that the system is organized in 3 dimensions rather than projected into order by accident. If the alignment dissolves the symmetry, then 3i Atlas will still give something valuable, because a broken pattern is not a failure, and 3i Atlas would simply be telling us that our model of orientation was incomplete. Either outcome becomes data, and data is the only currency that matters when a mystery becomes tempting. 3 I at last does not owe us a dramatic conclusion, and 3 I at last does not need to satisfy the stories we are eager to tell, because the universe has no interest in our preferences. 3 at last only needs to remain consistent with physics, and our task is to learn what physics is being expressed when the pattern appears and persists. The calm unease remains, because 3 I at last has already shown that precision can exist where we expected chaos, and 3 I at last has already pushed the boundary of what we casually call natural. And so the story stays open, not because we lack imagination, but because 3 I at last has earned the right to be tested one observation at a time. 3 I at last moves forward through the dark, and we follow with patience, because whatever 3 I at last turns out to be, the act of listening carefully is how discovery begins.